Today in Capechi's Corner, we're going to look at inscribed angles. An inscribed angle is an angle whose vertex is on a circle and whose sides contain chords of the circle. So for instance, different from a central angle whose vertex is in the center of the circle, we first have our vertex here, which is on the circle itself, and the sides are made up by chords. So our inscribed angle is right here. Our first theorem today states that the measure of an inscribed angle is equal to half the measure of its intercepted arc. So in our first example, I know that my inscribed angle is 40. So I know that the arc that it intercepts right here is going to be double that, so x has a value of 80. Now we could be given the reverse information. In my second example, if I know that arc is 52, I know that my inscribed angle is going to be half of that, so y has a value of 26. This theorem has three different corollaries, which we're going to look at next. The first corollary states if two inscribed angles intercept the same arc, then the angles are congruent. So what that means is if we're first looking at angle 1, the arc that it intercepts right here has a value of 160. So I know that the measure of angle 1 is half of that, which is equal to 80. Now if I look at the measure of angle 2, it also intercepts the same arc. So the measure of angle 2 is also going to equal 80. So as long as I recognize the fact that these inscribed angles intercept the same arc, I know that the values for these angles are going to be the same, therefore they're congruent. Our next corollary states that an angle inscribed in a semicircle is a right angle. So I can see that this chord right here goes right through the center, so it's a diameter, and I notice that this inscribed angle is inscribed in a semicircle because the chords match right at the end of the diameters. So therefore I know that that measure of that angle is 90 degrees, so it's a right angle. The next corollary states that if a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. So if you can see from the diagram, we have a quadrilateral, it's 4 sides, and each of the vertices are on the circle, so we know it's inscribed. So because of this corollary, we know that angle E is supplementary to angle G because they're opposite, and angle H is also supplementary to angle F. So if we look at some examples, for instance, if the measure of angle H were 110, then I know the angle opposite would be supplementary, which means they add up to 180 degrees. So that would make the measure of angle F equal to 70. The same thing is true for the other set of angles. So if I were to say that the measure of angle E is 60, I know that the angle opposite the measure of angle E, which is G, is supplementary, so that would give you a measure of 120 degrees. Our last theorem for today states that the measure of an inscribed angle formed by a chord and a tangent is equal to half the measure of the intercepted arc. So this is very similar to the last theorem we did. The last theorem talked about two chords, and this time we're talking about a chord and a tangent in dealing with the inscribed angles. So if I tell you the measure of arc AT is 140, this piece right here, then the measure of angle ATP, this angle right here, is going to be half of that. So that measure of angle ATP is equal to 70. Now we're going to practice using the theorems that we just learned. Find the values of the given variables. So if I look at my diagram, I realize I have a quadrilateral that is inscribed in the circle. So I know that if I have the letter X and 76, that the opposite angles are going to be supplementary. So that gives us a value of X equal to 104. Now, if X is 104, it's an inscribed angle. So I know that this whole arc right here, the intercepted arc, is going to be double that, which is 208. Now I realize that I have two congruent chords here, and congruent chords have congruent arcs. So if that whole arc is 208, because I know that these arcs have to be congruent, that makes each of them 104. So by doing that, I realize that Y has a value of 104, that arc. Now I'm trying to find the value for Z. I have a chord and a tangent, which is forming the inscribed angle. So that inscribed angle is going to be half the measurement of the arc. So Z has a value of 52. Let's look at one last example for today. It says find the values of the given variables. So I realize I have a few things going on here. I have a couple chords inside the circle, I have a tangent here on the outside, and I do have some arc measurements. So the first I'm going to work with is I realize I have an arc here of 100. The inscribed angle is going to be 50. And because these chords are parallel, I realize that x and this measurement of 50, they're alternate interior angles, which are congruent. So x is going to have a value of 50. Now that x has a value of 50, x is also an inscribed angle. So here's an inscribed angle. Here's the intercepted arc. So the intercepted arc is twice the inscribed angle. So I'm going to mark that. So that gives y has a value of 100. Now I notice within the circle that has a total measurement of angles of 360, I have 100 here and 100 here and 90. So that gives me 290. The missing piece right here is going to have a measurement of 70. So that's the only part of the circle that isn't marked up. So because that's 70, and z right here is an intercepted arc using a chord and the tangent, so it's going to be half of that. So z has a measurement of 35.